Okay, let me start. Good morning, good afternoon, and good evening. Welcome to the week 3 for S2S monthly webinar. Today's session features two distinguished speakers, Timothy Higgins from CU Boulder and Dr. Yongkang Su from UCLA. For further details and these resources, kindly refer to the week 3 for S2S website provided in the chat. In addition, we encourage active participation through the discussion document available in the chat as well, during and even following the webinar. So both speakers will contribute to addressing any questions or comments you may have. Okay, looking ahead, our next webinar is scheduled for October 7th at 2 p.m. Eastern Time. Okay, let's make a head start of the team.
Hi everyone, I'm Tim. For those of you who don't know me, I am currently a PhD student at CU Boulder, and today I'll be presenting on subseasonal potential predictability of horizontal water vapor transport and precipitation extremes over the North Pacific. And I would like to make a special acknowledgement to all of my co-authors who have been excellent collaborators and mentors on this project and beyond. So this study was initially motivated by a previous study from Lavers et al. 2016 that examined the differences in the potential predictability of IVT and precipitation at the medium range, and it found that IVT had higher predictability than precipitation does. At the medium range, I wanted to take this a step further and investigate some of these differences in the subseasonal range. So the project goal here was first to determine whether these differences also exist in the subseasonal range, and if they do exist, then to what extent do they exist, and then also potentially try and explain why they exist. And I am proud to say that this work was published about 2 months ago in Weather and Forecasting. So if you're curious to learn more after this talk, you can read the paper. So just like Lavers et al. 2016, we looked at potential predictability, which is a little bit different than actual predictability, as illustrated here in this figure by Kumar et al. 2014. Potential predictability has a perfect model assumption. So you can always expect potential predictability to be higher than actual predictability, but it can be useful to investigate some physical relationships. Here I use ECMWF reforecasts. I use rock scores as a skill metric and lead times of 3 weeks and 4 weeks integrated over 7-day windows. I had a target threshold of greater than 90th percentile conditions. So I didn't look at the potential predictability of IVT and precipitation overall. I only looked at these extreme greater than 90th percentile conditions. Just for anyone who needs a quick refresher on how potential predictability works and how it's different from traditional predictability. In traditional predictability, typically we take some forecasts, whether it's stochastic or deterministic, and we compare it to some reanalysis and then input the reanalysis and the forecast into some skill function and then estimate skill from that. Potential predictability is a little bit different in that instead of having any kind of reanalysis for verification, we use a single ensemble member for verification. So we have our model observation ensemble member, and we compare that to our forecast ensemble members, input that into the skill function, and then estimate skill. And we iterate through all of the ensemble members to allow each ensemble member to function one time as our model observation ensemble member. So when I calculated potential predictability, here's what I found. The shaded areas represent the rock scores at week 3 and week 4. We have week 3 in the left 2 panels, week 4 in the right 2 panels, and then IVT in the top 2 panels, precipitation in the bottom 2 panels. And I also used a Mann-Whitney U-test to demonstrate locations in which these forecasts were skillful. And so what we find here is that both IVT and precipitation both have some forecast skill in the North Pacific out to week 4. That is significant. So then looking at the differences in rock scores here, I just took one skill plot. So I took the IVT skill plot, I subtracted the precipitation skill plot to find the difference. And so anywhere where you see pink, IVT was more skillful, and anywhere where you see green, precipitation was more skillful. I used a student t-test to demonstrate locations in which the difference in predictability was significant at the 95% level. And so the main takeaway here is that we certainly see a lot more pink than we see green, which indicates higher skill for IVT, and we see many locations in which these differences are significant. So taking this a step further, after we established that these differences do exist and that IVT does have greater skill, I wanted to try and see if we could, at least to some extent, physically explain this difference in forecast skill in the subseasonal range. And so I turned to these North Pacific Jet EOFs that were introduced by Winters, Kaiser, and Bossart 2019, and specifically looked at the relationship between the jet extension regime, which is shown in the top left panel, and the predictability of greater than 90th percentile conditions of IVT and precipitation. Another previous study, Winters 2021, looked at the actual predictability, not just potential predictability, of these same North Pacific jet regimes in the subseasonal range, and found that there is actually some actual predictability of these regimes out to week 4. And I specifically focused on looking at the predictability of IVT and precipitation in this golden box here for 3 different reasons. The first being that this region here, which I define as the jet exit region, is directly impacted by this jet extension regime, which is shown in this figure. The second reason being that with the plots I had previously shown of where IVT and precipitation are both skillful, both IVT and precipitation have some forecast skill out to week 4 in this box. And then the third reason being that it is reasonably close to the coast, so that there are potentially some impacts some impacts of the conditions in this box on the US West Coast. And that's what I try to demonstrate here. So on the left, we have Era 5 conditions, and on the right, we have our ECMWF model observation conditions. And so in the top 2 panels, what you see is the IVT anomalies during weeks of greater than 90th percentile precipitation that is on the US West Coast. So when we have greater than 90th percentile precipitation on the US West Coast, you can see upstream that there are some positive IVT anomalies sort of within that jet exit region box. And that in the bottom 2 panels, we have the precipitation anomalies during greater than 90th percentile IVT in this jet exit region. And what we see here is that when IVT exceeds the 90th percentile in this red box, we see downstream positive precipitation anomalies that are on the coast, which indicates that there is actually some value in being able to predict IVT in this jet exit region. You may notice that the Era 5 and ECMWF precipitation plots do look slightly different, and I found that was almost entirely due to large differences in resolution, Era 5 being 1.5 degrees and Era 5 being 1/4 degree. So then I wanted to generate some error bars to kind of estimate how common this is. And I used bootstrapping to do this and found that in about 80% of cases, IVT has higher forecast skill in this jet exit region, but that is not the case 100% of the time. And so I looked a little bit further to try and understand how differences in the local variability of IVT and precipitation might impact this predictability gap. And so what I first did is I calculated the rock score at each individual grid point in the box, and then took the mean rock score out of all those rock scores at individual points. And so I plotted the mean rock score at each lead time up to week 4 here, and we find that the diamonds, of course, represent lead times in which these differences were significant at the 95% level. So at every lead time up to week 4, when we do this, these differences are significant, and these differences clearly exist. Then I took a slightly different approach, and I took the average of conditions within the box before computing the rock score. So when I did that, that kind of eliminated a lot of the differences in local variability. And so what we find is that this skill gap closes considerably, but we do have many lead times, particularly in the sub-seasonal range, where these differences remain significant. So there is more going on beyond just this local variability. And we actually see less lead times in the medium range where these differences are significant. So it appears to play a larger role in the medium range. And so here's a side-by-side comparison of both of these plots. Of course, you can see that skill gap closed considerably. And so then I wanted to further investigate the relationship between the predictability of this North Pacific jet extension regime and the predictability of IVT and precipitation. And I used this North Pacific jet phase diagram, which was also introduced from Winters, Kaiser, and Bossart 2019 to try and illustrate this. And so any PC value that is in the triangle on the right represents a jet extension. The top triangle is a poleward shift, the bottom triangle is an equatorward shift, and the triangle on the left is a jet retraction. So I looked at these North Pacific jet regimes that were model observed during model observed greater than 90th percentile conditions for both IVT and precipitation. And I also used red and green representing skillful forecasts and red representing unskillful forecasts. And so what we see here is that the mean jet conditions do not fall into any regime when precipitation is not forecasted skillfully. But when it is forecasted skillfully, we do see that jet extension regime existing. For IVT, when IVT is model observed to be greater than 90th percentile in this jet exit region, there's always going to be a mean state of a jet extension. However, I found that when these forecasts of IVT are skillful, that the jet is extended a bit farther than when these forecasts are unskillful. And I used a student t-test to find that these differences were also significant at the 95% level. I then sort of did the reverse and looked at the model observed conditions of IVT and precipitation during a model observed greater than 90th percentile jet extension regime, and then split that up for skillful and unskillful forecasts of the North Pacific jet. And what I found here was that when the North Pacific jet extension regime is predicted skillfully, we do have greater precipitation anomalies that are on the coast, whereas when it's not really predicted skillfully, we have not only less precipitation anomalies, but in some cases dry precipitation anomalies. And then taking a difference plot between these two, I find that not only is it precipitation that's greater during these skillful jet extension forecasts, but we do also have greater IVT near the coast during these skillful forecasts of the North Pacific jet. And I used dotted marks to show locations in which the precipitation difference here is significant at the 95% level. I then wanted to get a little bit of a better understanding of what is going on in the forecast when we do model observe greater than 90th percentile IVT in week 4. So here, lower level 850 millibar geopotential height anomalies that are forecasted are shown from week 1 until week 4 in the shaded contours. And then the line contours, we have upper level 300 millibar geopotential height anomalies. So when we model observe IVT in the jet exit region to be greater than the 90th percentile, starting from week 1, we're already starting to see anomalously low geopotential heights. And that lasts all throughout the 4-week forecast, although from week 1, it tends to shift towards the southwest and then strengthen. I then looked at standardized ensemble spread, which is shown in the shaded contours here. The lined contours show during these skillful forecasts the 300 millibar geopotential height anomalies that are also forecasted. And so we're looking only at skillful forecasts and looking at the standardized ensemble spread. And we see that in the tropical western, northwestern Pacific, we see anomalously low ensemble spread, and also anomalously low ensemble spread in the northwestern Pacific, kind of in conjunction with a forecasted very anomalously low geopotential height anomaly, which is strongly associated with that jet extension regime. Additionally, looking at the Rossby wave source that is forecasted during the skillful forecasts of IVT, we see kind of upstream of that jet exit region, kind of in East Asia and the Northwestern Pacific, we see an anomalously high Rossby wave source. And then I plotted the stream function in line contours, which sort of shows the direction of flow. And what we can take away from this is that these areas of anomalously high Rossby wave source sort of coincide with those areas of anomalously low standardized spread. So in order to have these skillful forecasts of IVT, there needs to be that anomalously low spread in the tropics and kind of in the Northwestern Pacific, where this anomalously high Rossby wave source is occurring. And so I had several interesting takeaways from this work. First, we see that there is some potential predictability of both greater than 90th percentile IVT and precipitation weeks that exists out to week 4 in the jet exit region. I found that IVT generally has more forecast skill than precipitation does over the North Pacific at subseasonal lead times. I found that local variability cannot fully explain the differences in forecast skill, and I found that the strength of the North Pacific jet can have a significant impact on the predictability of both IVT and precipitation in the subseasonal range. If you have any questions about this or anything else after this talk, feel free to email me. I don't bite. Here's my contact email, and I'm happy to answer any questions that anybody has here.
Sounds good. Yeah, it was a great talk, and thank you, team. Any other questions if you have, the audience? You can unmute and feel free to ask questions or comments. Or please put any comment or question in the discussion document, which I posted in the chat box. Okay, I have a quick question. So is the jet stream directly related to the atmospheric rivers on the U.S. West Coast?
Yeah, I found that greater than 90th percentile IVT
Okay.
is strongly associated with how atmospheric rivers are defined in many Hartman detection algorithms. So while that doesn't completely define an atmospheric river, greater than 90th percentile IVT is certainly strongly associated with atmospheric river activity.
Okay. Yeah. Statistically. Okay. So if so, why is there currently a severe annual variation in the jet stream? Is that maybe like beyond the scope of the talk? So I'm just, sometimes some years huge snowfall in the U.S. West Coast, but some years very drought, right? So, but severely impacted by jet stream, which is the main driver of the atmospheric river. So is there any kind of finding why annually that jet stream is varying too much?
Yeah, I mean, you can connect it to other teleconnections like El Nino, the MJO, the PNA, and so on.
Mm-hmm.
But this was just a different way of looking at it in kind of a more localized way, and just directly focusing on the North Pacific jet. So I'm sure if you did look at other teleconnections like that, you might see some similar type of interesting result that you could take away from this.
I see. Yeah, which is a different angle. Okay, got it. So another question is that your group do the computational modeling, or you guys are depending on the reanalysis data sets such as ECMWF or ERA5 to conduct the precipitation skill?
Yeah, so in this study, we only needed ECMWF reforecast from the ECMWF.
Understood. Okay, maybe first question is not relevant. Okay, all right, thank you so much. So again, please, I posted the discussion chat box, so please post the question and then team will actively address all of the questions and comments. Okay, thank you, team, again.
Thank you.
Mm-hmm. All right, so let me move to the second speaker, Young Kang. I'll make you the presenter again.
Okay.
Yep.
So can you hear me?